What's going on, everyone? Steven here. Today we're going to talk about cheat engine, memory, cheat tables, and hopefully I'm going to demystify a lot of things for you and make cheat engine less of a black box, that just kind of does things and you don't really understand how it works or why it does what it does. And basically I'm going to demonstrate my points using kind of a script template that I like to use most of the time nowadays. Alright, so the game I'm going to be using this with is Bloodstained Curse of the Moon. It's a really fun Castlevania type of retro game. But anyway, these days what I like to do is, usually as you're going through and you're finding things and creating scripts, if you're doing an AOB scan, you'll have this alloc new mem, right? So it allocates memory, and you might be inclined to, let's say you're wanting to create your own pointer to something, you might alloc, let's say it's a cam base for like the base of camera coordinates or something. And that base address is going to be, a 64-bit address, so you want to allocate 8 bytes for that, right? Well, basically when you alloc like this, 8, Cheat Engine doesn't just allocate 8 bytes. It allocates a minimum of 4K. So this is 1000 hex, which is 4 kilobytes of memory. And that's a standard page size. Alright, so if you have some questions about that, we're going to be Googling stuff and whatnot here too. So, like 4K page size, right? And you can read into why things are 4K, 8K, whatever, blah, 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 right? So you can read into that. Standard size of a page, okay? A page of memory, like a page in a book, a page of memory, you have so many bytes that you can write to, okay? So Cheat Engine, no matter what you specify here, it's always going to allocate 4K. So if we say 1001 hex, then it will allocate 8K. Okay? So, yeah, that might come in handy for you later. Like, as we get into what I'm going to show you, you might have a reason to actually get in beyond 4K, and you can do that. So, instead of creating a bunch of scripts, like let's say we have a cheat table with like 15 different scripts, and you're allocating 15 times 4K. That's ultimately that's not a lot of memory at all in the grand scheme. Like whenever you have 8, 16, 32 gigabytes of memory, that is a ton. So typically you don't have to worry about this stuff, but I think it's fun to kind of manage memory a little better. So that's kind of why I wanted to talk about this. So anyway, so what I like to do is birthed out of not allocating new memory, right? I like to allocate memory once and then use that 4K of memory for the rest of my cheats. Okay, so I'm going to close that without saving any of it, and I'm going to open my template here. All right, so the first thing you'll see is I have a legend. So, where at in my allocated memory are the addresses, housing the bytes for my cheats. And that'll make sense in a little bit, so don't worry too much about that for now. So when you enable the script, what it does is it allocates 4K of memory and creates a label called membase. So memory base, that's just what I call it. This is an optional parameter here, okay? And this tells Cheat Engine to allocate memory pretty much within a distance of this module, a certain distance. And let's just, to explain that better, let's go Cheat Engine Wiki. Okay, and we go here to wiki.cheatengine.org. We can go into autoassembler commands, and we'll go into alloc. Right? And so you can read about exactly what alloc does, the parameters that you pass, and what's optional, right? So you don't have to specify this. You can read why that is the way it is and keep reading through here, different things, right? So even though it shows this example here of alloc and then only 4 bytes, here's what's cool. Starting at this base level of just allocating memory, right? We can go validate, we can see what Cheat Engine has done, okay? So first, let's talk about the differences between a label and a symbol. So register symbol. A label, my label, as opposed to a symbol of my label, okay? A label is something that can be used within this script. So if I have another script and I want to reference my label, right, I need to register that as a symbol. So registering a symbol creates something that can be seen globally. Everything can see it. Otherwise, what it would be is like my label. Here within the script, I can do something db1337, right? And anywhere within the script I reference my label, it'll know what that is. But if I were to save this, run this, and then open another script here and say my label wanting to reference this, if I haven't registered it as a symbol, then Cheat Engine won't know what that is. Okay, so to make more sense of that, okay, let's just go ahead and we're going to enable this memory script. All right, I'll close it and make sure that I don't have any changes, whatnot. Okay, enabled. I'm going to go to memory view here, and now I'm going to look for this symbol name, membase. So you can right click in here and say go to address, membase. All right, Cheat Engine knows where that is because this is the symbol that has been registered for global reference. So now any of these scripts referencing membase will know where in memory that is so that it can write or do whatever you want it to do. All right, so in this case, right, I'm allocating the memory. All right, now look here. So 1000, okay, where was this allocated at? This was allocated at 00A00000. And the way I know that is what you can do is view, turn off show module addresses, or I'm sorry, show symbols, turn off symbols. And there you can see the actual address that it's at. So A00000. So since we allocated 1000 hex, all right, if we go 1000 from this number, so 6, 7, 8, let's go all the way to 1000. C, D, E, F. All right, 1000. Look, see all the question marks? All right, so this is a 4K allocation of memory. This is what Cheat Engine allocated. And now what we can do is we can right click here and say go to address, membase, just to go back to it. I'm going to re-enable show symbols and show module addresses. Now what we can do is we can go and view memory regions, right? And we can look for the 00A. Right, 00A. And here we go. This is the memory region that Cheat Engine has allocated, and it's given execute, read, and write permissions. Okay, so I'm going to keep that here. All right, and now I'm going to disable this script, and now I'm going to go view memory regions again. All right, we get a second one up here, and let's look for that 00A. All right, 00A1. All right, that's not the same region it had allocated. So you see, it's gone. And why is it gone? Because we disabled the script which deallocated that memory. Okay, so that's what's going on with alloc and dealloc. Okay, we also unregistered the symbol, so that's why that went away from here. Okay, and you see all this crazy stuff going on, and that's because who knows what's going on with memory in some of these areas. Presumably like a free area of memory that can be used. So, and with memory regions, you can go through and find all kinds of stuff through here. This is presumably showing you memory regions of, everything that it sees in relation to, well, this is like a 32-bit space, so everything at the highest end of 32-bit, right? You can see which files are where, and files have different things that they're using in different regions of memory. So here, cotm.exe, this is the game, right? So these different regions of memory are, different things. So what we can do is we can go see, let's go to cotm.exe. All right, this is the start of this executable, this program, the game. This is the start of it in memory. And now if we want to see the actual address, we could just go look here, right, and it's going to give us that. Or we could go to View, and this is where we can untick Show Module Addresses, and there we go. Okay, View, Show Module Addresses. Okay, so this is just kind of demonstrating what's what in memory and what's going on there, and labels and registering symbols, blah, blah, blah. But anyway, so if we go back to this page, we can see here from Sunbeam, who is a really awesome game hacker, by the way, CE actually fetches the module. Okay, and when you see module, that's just the executable, right? This is a module. So when you see show module addresses, it just means the executable, the program. That's the module, okay? And allocates close to the end of the module. Additionally, specifying an offset does not add to it in any way. All right, so what he's saying there is, so what you can do here is you can say, like sometimes you'll do an AOB scan. Let's say you find something here, you're in the disassembler, you do a new AOB scan, tools, autoassemble, template AOB injection, right? And so you get this, and then you'll get whatever you want to, have for your name there. Okay. Sometimes right here you'll see maybe like cotm.exe plus 1D47C or whatever. So it's basically saying allocate memory near this specific place, right? And that again has to do with this like 2 GB limitation for a distance of jumping. All right, so anyway, basically what Sunbeam is saying is this offset doesn't matter. Whether we specify 1D blah blah blah, or we specify just the module, it's going to allocate where it's going to allocate towards the end of the module. Well, guess what? We can verify that if we want. We can come into our script here. Okay. And we can look how we have it right now. We're specifying just the module. Say OK. We're going to enable this. Right click here. Go to address. Oh, hang on. Before I do that, the last thing I wanted to show is we also can verify that this is the start of this module being imaged into memory by looking at these bytes, right? So these bytes in the disassembler are being interpreted as instructions because this is the disassembler, this is the memory viewer. So we can go to this address here in the memory viewer as well. So let's go to address, cotm.exe, right, 4D 5A90, 4D 5A90. That's why sometimes you'll see some really funky looking bytes that just don't quite seem to make sense or be right, like if you've read through enough assembly, you know what I'm talking about. And that's because you're probably in an area of memory where the bytes aren't instructions. They're actually like data or something. So you should be looking at whatever region you're in down here in the memory viewer, right? And then you can look over here and see if there's any sort of ASCII representation. And look down here, we've got a text section, we've got our data, so we know that we are in, you know, the header of this executable that's been imaged into memory. And finally, another sign is byte 4D5A. Okay. Google, well, let's see, byte 4D5A. Look, DOS MZ executable, which is also the PE or portable executable file format, right? The magic for it, the first 2 bytes are hexadecimal 4D5A, which is MZ. Why is it MZ? MZ are the initials of this person, one of the lead developers of DOS. Anyway, so we're seeing all this stuff in memory. We're making sense of it, right? We understand what we're looking at now. So anyway, let's go back into here. I've enabled this. Now I'm going to go to address membase. Okay. And where are we at? We're at 00A, you know, 000, blah, blah, blah. That's where this was allocated. Okay. Let's deallocate. It went away. Let's come in here. Let's specify an offset. Plus 9999C. Let's say OK. Let's allocate. It allocated to the exact same place. Interesting. Let's deallocate. So, correct. The offset did not matter. However, I'll show you something in a second here. Let's do this. Let's not specify the module there. Let's say OK. Re-enable it. Ooh. We're not getting it there. Where did it allocate to? Let's go to address, membase. Here we are. 008F 0000. That's where membase is when we didn't specify the module. But where's the module at again? So the memory that we're allocated at here is 008. So let's go to address cotm.exe. Alright, that was 008. This is 00F. So since we know that this is the start of the executable in memory, it's actually allocating well before where it has, you know, the executable in memory, which contradicts this part about CE fetches the module and allocates close to the end of the module. That's not true. It might be true. It might do that in some cases, but I don't think this is, by and large, correct. So anyway, you know, when you come into the wiki, don't take everything, you know, as fact, because, you know, you may find some things like that. Go check it out yourself, you know. So anyway, that wasn't to prove Sunbeam wrong. I just, you know, whenever I saw this, I was like, huh, is that true? Let me go check it out, and then you see what I found here. Right, so anyway. All right, so I'm going to disable that, come back in here, cotm.exe. Just keep it back in there. I generally, as a template, I like to keep that in there because, you know, this will help with the 2 GB issue. And that problem will manifest itself if you have written a script and you're like, I know this script is right, but why is it not enabling? A lot of times it will be this alloc that you have in there that, whoops, that you're not specifying the module there, so it's allocating somewhere in memory that is outside of that 2 GB jump limitation, right? So, nice to know thing there. All right, so that's sort of this. This is allocating memory, registering a symbol so it can be seen globally by everything. Making a label. Let me show you one more thing about the label here. Okay. So what I'm going to do now is say label code. Now I can come in here and have code. All right, and then I can db 8008, right? So let me say OK, enable, let's go to address membase. Okay, see these bytes here that have been allocated, and these, and then 8008. Right, so it literally allocated these bytes here, which I'll be explaining these in a little bit. Right, we see them here, and then directly after that it allocated, or wrote these bytes rather. I keep saying allocated, I meant wrote. So it's written these bytes. Okay. Now what happens if we disable this and we put code before membase, and we say OK, and we enable it. Now what did we get? All right, we get these. Okay, we don't seem to have gotten that allocation, right? Why is that? Because I didn't enable it. Oh my goodness. Alright, so the problem here is that I guess I made my change and I saved it without deactivating it, perhaps. So let's get rid of this stuff here. Okay, let's say OK. Right, enable, disable. Hang on, because the symbol isn't written there. So, alright, it's just going to allocate new mem somewhere else. So, go to address new mem. I'm sorry, mem base. I'm still used to saying new mem. Alright, so we're in a different place because it's not going to allocate to that same place because I goofed up. Right, so anyway, let's start back over here with this. I'm going to deactivate that. Let's come back in here. Say again, label, code, DB8008, and now we say OK, and then we enable it. There we go. Okay, so yes, we can see that we're having this issue. It wasn't me. We're having some funkiness happen now with the script because of how this has been done, right? So having this code out of order with this membase is screwing some stuff up, right? And why is that? Because we're allocating memory membase, right? We've got this literally coming before membase, all right? We need to have it after membase, right? Because it's going to see that this is the region of memory, wherever it's allocating that at, it's going to declare these bytes, and then with this label here of code, it will declare these bytes directly after these bytes. It's doing it from top to bottom like we saw it, right? So now here we go, another region of memory that's kind of screwed up. Not a big deal. Okay, it serves the point here. So this is one way that you can have your code written. But what if we don't want these bytes to directly follow these, right? So let me come back here, say OK, enable it, go to address, membase, okay? We've got these bytes, then we've got the 8008, right? What if we want them to come somewhere after that? All right, so what we can do, I'm going to disable that, and instead of doing a label, I'm going to do a define. So I'm going to define as code membase plus an offset of 20. Okay, so now Cheat Engine knows that this spot code, right, still to be used here in the script. This is basically creating a label that, you know, within our region of memory that's being allocated, okay, it's going to place our bytes in a direct spot that we want them to be in there, okay? So now if I say OK, boom, look here, 90, offset 20, there's our bytes, okay? So that's how another way that you can use define. So this gets to the point of where sometimes I'll want to use the same memory, and or the memory that's allocated, I want to use that same memory across all of my cheats, right? So if I'm going to create my own pointer or something like that, I can define, my pointer as membase plus whatever I want, plus 100. And then, if I've done that in another script, like let's say I've done it here, define membase plus 100, right? Like here, I've done it. Well, here I'm referencing membase plus 100, and this script knows where that is because the symbol has been registered. But that means that for this script to see that, this one has to be enabled, right? Because that's when the symbol is created. All right, so I'm going to go ahead and get rid of that code. I'm going to get rid of this. All right, and I think that puts me back at what I was originally at. I'm going to say OK. Close that. We'll close that. And this. Okay, so now if I don't enable this, okay, and let's say I'm go to address cotm.exe plus 13d89, whatever, right? All right. So let's say I'm wanting to create a code injection here. Tools, auto assemble, template AOB injection. We'll say OK. OK. All right. And now let's say, we were going to jump to membase plus 500. All right. If I go File, Assign to Current Cheat Table, I get this error. Error in line 20, blah, blah, blah. This instruction can't be compiled. Oh, wait. Let's comment that out. We're in a funky region of memory, and that doesn't make any sense to it, I guess. So, File, Assign to Current Cheat Table. Okay, here we go. Error in line 21, jump to this location, right? This instruction can't be compiled. That's because it doesn't know what membase is, right? So the first time you go to actually make a script like this, you need to have this enabled because bam, now the symbol has been registered. This means something to this script now. So I can go File, Assign to Current Cheat Table, and bam, there it is, right? Now after you have assigned it, right, if you want to modify it later, I don't need to have this enabled, but it'll say, like let's say I click OK now, and see here where I'm referencing that. Not all code is injectable. Error on this line, right? The address specifier is not valid. Are you sure you want to edit this? Yes, we know it's going to be valid by the time we enable this script, right? It's just saying I don't know what the hell membase is, right? So that's the difference there. That's one little bug you might have initially encountered if you decide to start going this route. I just kind of wanted to explain that in case you run into it. Alright, so I'm going to enable this, and this now allows me to enable any of my other scripts where I'm referencing membase, right? So the first thing that I like to do, let's take infinite magic here in this case. Okay. Originally, I found what reads the value. I'm going to copy this address, go to that address. Whoops, I copied the bytes too. Go to address. Okay. What? Go to address. Let's try this one more time. Oh, because it got one of the quotes. And the bytes. Double whammy. Okay. There we go. So here, with these instructions. Alright, I'm back. I had to step away for a moment. But anyway, getting right back to where I was. So I'm just going to come in here, Tools, Auto Assemble, Template, AOB Injection. Copy that. I'm going to say OK, and I'll name this like Magic Scan since it's a scan that we're going to be doing here, essentially. And so instead of doing the AOB scan, because this is a very process-intensive thing to scan the module for these bytes. It can be. This is a very tiny application, so it would not take very long. But if you have like a really big application, then it can take a while for your cheat to enable. you may have noticed if you've used certain cheats, it can take a while before it enables after you click it. It's probably because it's doing an AOB scan, looking for the correct bytes to do everything with. So instead of doing that, what I'm going to do is reference the direct, the module plus offset. So let me turn back on show module addresses. And so what I'll do now is, I still like to do the whole AOB thing because it gives me a snapshot of code. So if there's like an update to the game or something, and the array of bytes break, or the script basically stops working, this can kind of tell me a lot to lead me back down the right path if I need it, to have this code snippet. And then I can just comment out the AOB scan module portion in case I need it. So instead of doing that, since I copied this address when we first, said to do this script, I'm going to first assert something. Okay, then I'm going to define something. Actually, I'm going to assert two things, and I'll show you what that is. So first, assert means make sure that in this memory address there are these bytes. That's all it means. Okay, so the first assert that I have, that's why I have these bytes here written to membase. Okay, I've got dead beef, leet, feed. Presumably, this will, not that there would be any conflicts for any reason, but anyway, it's just a quirky little thing for me to reference, whatever. Alright, so at membase, okay, I'm going to assert that at membase we have these bytes. Right? That makes sure that before this script enables, it is going to make sure that this first script is enabled, right? So first of all, I have two checks that I do. Typically, if you were to open this cheat table up for the first time, I have the group config set to hide children when deactivated, so you wouldn't even see any of these scripts beneath this. The user would have to enable this first. But say they knew to go in, or they were just futzing around and went to this and then unchecked that, and they could see all these. I've still got this assert in there to keep them from enabling the script. Alright, and that keeps it from breaking with all the memory references that I have to membase. Okay. The second thing I want to assert is that at this address here, right, the one that we based the scan on originally, which we can see here, injecting here. So the next thing is at this address, we have these bytes. Alright, so that's that assert. Alright, so if these two asserts pass, then the script will enable. Alright, and when it enables, it's going to define, oops, not the bytes, we want this memory location as this label here, magic scan. Okay, so it does its two asserts. First, it makes sure that my script is enabled for memory. Then it makes sure that at this memory address, it is the bytes that it expects to have there. Then, if those pass, now for magic scan here and everywhere that magic scan is referenced in the script, right, we have defined that location as here in memory. Just like the AOB, we're basically doing what this AOB scan does. It scans this module for these bytes, and if it finds it in memory, the script enables, and this is the label that's applied, right? Which means anything in the script can reference magic scan. But that's why a symbol is also registered as magic scan, so that it can be referenced, outside of the script or in a global context. Alright, so once I've done those things, alright, I can get rid of this alloc because I'm going to use my memory. right? I'm going to get rid of that. I'm going to also get rid of code here. I'm going to get rid of code there. All right, and instead of new mem and jumping to new mem, I'm going to jump to memory I've already allocated. Okay, so I'm going to get rid of this dealloc as well, because we don't want to deallocate anything. We're not allocating any memory in this script, right? So I'm going to move this register symbol up here under this define, because I like to keep it all nice and tidy up there. All right, so this script is getting cleaned up nicely, like how I would do it. All right, and finally, so this scan or this thing happens, the script enables, all right, and it needs to know where to jump to. So we're going to jump to, well, where do we want to jump to? Membase plus 100, all right, and that will be here, membase plus 100. So because these are the only two places I have membase plus 100, you know, there's no label or anything that's been defined here, which is why I would get that error if I went ahead and tried to say, well, now I wouldn't get it because I have that memory script enabled, right? So this is where my legend comes into play. I like to know that, okay, if I want a quick glance at which scripts here are doing what, right? I have the scripts in the same order top to bottom as I do top to bottom here. And this just shows me that for infinite magic, those bytes are at membase plus 100. For infinite health, it's at membase plus 200. These are arbitrary, nice offsets. You know, if I'm going to have like 50 cheats or something like that, I may rethink this. I may not go through all this, right? Because that would be a lot of doing all this, and it just might not be worth it time-wise. Or if you want to mess with being as optimal as you can with memory, you can take what I discussed before about where to write bytes exactly. You can go see exactly how many bytes are being taken up with any script that you enable, you know, and just make your offsets accordingly. Like maybe this would be membase plus 20, and then this one would be membase plus 3C, you know, because this one only used however many bytes, and this picks up where that left off, you know. So anyway, that's what my legend is for, so I can always open this file and see what's where. I can also assume that because I have these four, we're not worrying about these collision ones right now. For these four, I know that since I do offsets of, you know, 100 for each thing, you know, I can also look at these and know that that one's at 100, 2, 3, 4, blah, blah, blah. So there's a nice continuity there. But anyway, so this whole thing has been explained to you. You know the purpose of this whole thing for me, right? These bytes, the allocation and deallocation of memory, why a symbol is registered. If we wanted to have a label and write certain bytes directly after this, or define our own spot within membase, right? So I'm going to close that, and this here is pretty much done. All right, the script would be where I wanted it to be for this cheat. And so this would be the magic scan. Now if I actually open the magic scan, which was the one I copied before, okay, these should basically look identical. All right, with the exception of a couple of other things that I added in, my cheats, but we're jumping to the same location, blah, 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 right? So with the actual one here, you'll notice this, right? So I'm going to close this because I don't need it anymore. That was good for an example. In the actual one here, this was where the code came in. So the two things that I added in were this, and here I have a little comment saying what this instruction does. So I increase max weapon magic to 99. That's this number right here, the 5. And I also increase, or I'm sorry, max is the one on the right here, the 20. And then the current one is 5. So I set both of those to 99. Right, and I found an instruction that reads, so the moment I enable this, we should see these both change to 99, and we do. Right, so that's that. Now, I encountered a bug where whenever I defeat a main boss, my score keeps counting up, 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 and it never stops. All right. So the reason it does that, and the bug, is that it also wants to count this down. But because of my cheat here, always writing 99, it was conflicting with what the game wanted to do. So basically, whenever you're fighting the boss, or you're done fighting the boss and it wants to count this down, there is a different instruction that there are two different instructions. One that subs, it counts this number down, and the other that compares the number to 0. And when it's 0, it knows, okay, I'm done, now go to the next screen, whatever. So all that I did was I found that instruction that compares to 0, and I instead made it compare to 99, which is 63 hex. Right, so since with this cheat on, it always will be 99. This makes it just not worry about counting down. It just compares to 99 and it says, okay, cool, move on, right? So a little bit of bug testing, I found that. So fix bug with boss, defeat, weapon, magic countdown. That's what that is. All right, so again, something else there for my sake. If I come back into this cheat table 6 months from now and I'm like, I have no idea what I did and where I found this, that, the third, blah, 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 you know, I can leave notes for myself. Other things may be super obvious. Like here, I can see that I'm moving 99 into here. I've got an idea of what that does, right? So see, well, health here, it will always stay that if I activate that, but score, watch these zeros, I'm going to enable that, boom, all 9s, infinite lives, watch the lives, number of 3 here, boom, 99, right? And so anyway, pretty standard fare there with all that. This is just my, you know, current approach to creating tables. You know, you don't have to do it. You can just keep doing this whole like default template stuff, do your thing, and just keep on rolling right along. But, you know, if you want to do this, cool, but I felt like me just explaining a little bit about what's going on in memory, how it all works, what's doing what when you enable the script, what allocates, register symbol, label, etc., what all that does and what it means. Demystifying it for you, hopefully. So anyway, I know this is a really long video. I appreciate you watching. I hope you learned something. Feel free to leave some comments. As always, there's more than one way to skin a cat. This is just my personal approach right now. You can also use something called global alloc, which I'm sure some people will comment about without quite having made it this far. Global alloc, you can go read about that. I always just like to use alloc so that I can deallocate that memory. Usually with global alloc, it will register a symbol for you, so you don't have to do the alloc and then register symbol. But with global alloc, it also allocates that memory to a specific region of memory that does not always play nicely with that 2 GB jump limit that we were talking about earlier. So I always do alloc and register symbol, and then I can deallocate that memory as well. So that's why I do that and why I chose not to use global alloc. Alright, so anyway, again, long video. Thanks for watching. Give me a thumbs up if you enjoyed it. If you're not subscribed yet, go ahead and do that. Check out my other cheat engine tutorials. I have a whole bunch of them. And yeah, that's pretty much it. So thank you for watching, and I'll see you all on the next one. Take care.